Hello guys, in this video we'll see a package from the Tidyverse library, that is ggplot2. So this is a very important package for graphical plots and so on in R. Okay, so yeah, so we'll see what is Tidyverse and we'll see ggplot. We'll see how can we do a scatter plot in it and a bar plot. Okay, let's get started. Okay, so first you'll have to load the library Tidyverse. So if you have not downloaded, you need to first install the package. I'll just quickly show you how. So install dot packages, and then you can type Tidyverse. Okay, so like this you can install this. Okay, you can, I mean, I have already installed, so I'll not run this command, but if you want to install, you have to run this command. Okay, so let me just yeah, so I've just run this command so that I have library tidyverse now. Okay, so before we learn about graphs, let us look the different types of data in general. So this will be helpful when we do when we plot a particular graph. Okay, so yeah, so there are like two types of data, discrete data and continuous data. Okay, so this comes under numerical data, so numbers. So if you have data like these, so this is a numerical data, and then in numerical data you have discrete and continuous data. Okay, so a discrete data is that can be counted, so you can count discrete data. I'll give you an example. They can take on possible values. The list of possible values may be fixed. It can be finite or it can be countably infinite. Okay. Uh, so this is like integers. I mean, you can count. It can go to infinite values, but then it should be countably infinite. Let's take an example. Okay. So this is a database. Empty cars. Let me just show it to you. So I've just called the head function, so it'll just show me the first six rows, and these are the different cars, and then the different attributes of the car, so like horsepower, gears, etc. Okay, so if you see gear, okay, so gear over here, so now gear is like a discrete value. Why? Because either they can be 4 or 3 or 5. Okay, you cannot have a car having 2.5 gears, not possible, right? I mean, you should have a whole number, so it's 4 or 3 or 5 or something like that. Okay, so this is finite. You can have only finite number of gears. You will not have infinite number of gears in a car. So this is finite, and this is countable. You can count it. Okay, so this belongs to this category. So this is fixed and can be finite. Okay, similarly, there is another thing over here, carb. So again, you can see this is taking 1, 2, 1, and so on. So yeah, so these come under discrete data, but then you can have something that is non-discrete, non-infinite. So this is like, this can go up to this can, sorry, so you can have something that is infinite. So this is finite. We saw that you can have gears that is finite, but so you can have an example of infinite, countably infinite, as students. So say a particular class has 100 students, another class has, suppose it's a big class, it has 1,000 students, or a webinar, so there are 10,000 students in a webinar, or say a particular number of students applying for a particular um, entrance exam, okay, appearing in a particular entrance exam, so that can be also in million or lakhs, right? So I mean, depending upon what is the scenario, you can have a large number of students, right? But then you can never have half student. I mean, it'll never happen that you have 1.5 students in a class, right? It should always be a whole number. So these are all discrete data. It can be countably infinite, or it can be finite. Okay, but then the main thing is that these should be whole numbers, or yeah, whole numbers. So it can have 0, 1, 2, 3, and so on. It should be, so it should be whole numbers. That's the point. Okay, so this is one data type, that is not data type but a type of data, that is a discrete data. And then you can also have continuous data. So continuous data is mostly measurements. They cannot be counted. So say if I give you an example, how many numbers are there between 0 and 1? So this is something that you actually cannot count. There are infinite numbers, but then that is not even countable. You cannot count it with your fingers. Where will you start from? So say 0.00001, but then you can also have 0. You can also have 0.0000001. You can also have 0.0000001. So you can keep on adding infinite zeros over here, and you see that you don't even know which is the smallest possible number after 0, right? So this is what we call as in uncountably infinite numbers. Okay, so these are continuous data. So like over here, for an example, if you see the weight, okay, so the weight is like 2.62, it can be 1.835, 2.875. You can have any number of numbers after the decimal point. This makes it continuous. You can have any number between on the number line, right? So this is what we call as continuous data. So these are two types in numerical data. And then there is categorical data. So categorical data can be person's gender, marital status, hometown, Mumbai, London, New York, etc. Can take on numerical values as well. So we can have, say, 1 indicating male, 2 indicating female, and so on. But then these numbers actually don't have a mathematical meaning. So this can either be 1 is equal to male, or also 0 indicating female. I mean, the maths is actually not important over here, but it is what it represents, right? So yeah, so you can have categorical data as well, and you can have numerical data. Okay, so example for categorical data is if you load this library, library mass, there is a way, a data set called survey inside library mass. So here you can see that there's male, female, and so on. So there is this one uh, column, and then this is actually a categorical data, either male or female. So these just have two levels, male and female. However, if you see smoke, so there is smoke over here. Now these the smoke has different levels. So either you never smoke, you smoke regularly, occasionally, and so on. So this has I guess three different levels. So this is again categorical data, because it's like this. I mean, okay, so I guess you understood the difference between numerical data and categorical data. And inside numerical there is continuous, sorry, inside numerical, yeah, there is continuous and discrete type of data. Okay, so this will be useful when you actually use the different plots. So like for example, let us go to ggplot. Okay, uh, so ggplot is actually a very big function. It consists of a lot of things. So I have given a link to this sheet, and this takes you to this GitHub link where there is this PDF. This actually contains a lot of functions that you can use and explore, and then find and then get whatever plot you want. Okay, so we'll not go into the details of everything. I'll just show you the important things that is required in ggplot, and then we will and then you can actually explore the other possibilities. Okay, so just this is just an introduction to ggplot, but then no, it does not contain everything. It is not exhaustive. Okay, so let's start with a scatter plot. So say we want a point graph, also known as a scatter plot. So how do you do that? So say I just call this air quality, which is a data set, and it looks like this. Okay, so these are all inbuilt data sets, inbuilt in R. So you don't need to download anything, you'll get this with R. Okay, so it has ozone, solar radiation, wind, temperature, month and day. So now if you see month, this is a discrete kind of a data type. So you'll not have 5.5 months. It'll be either 5, 4, 3, 2, 1, something like that. Okay. The day is also discrete, 1, 2, 3, 4, 5, 6. You'll not have 1.5 day. So I've taken, so this data is such that the data is taken every day. Okay, so the first day of the fifth month, this was the ozone, the solar radiation, the wind, the temperature. Okay, so if you want to have a plot between wind and temperature, you can just call ggplot. The first argument is the data frame. So which data frame do you want to give? So that's the first argument. It's okay even if you don't put data. I mean, it'll understand that the first quantity is actually the data frame. The second is aesthetics. That is what they call, because actually you can also change the aesthetics of this plot using this. But the important thing that I will focus over here is wind. So wind is nothing but my x-axis. So here in aesthetics you can actually define what is your x-axis and what is your y-axis. So wind and temperature. Where is this? And then you have to define this. That means, so this is like this will actually tell ggplot what kind of a graph do you want. So this says point, so I want a point graph like this. Okay, if you change this, you can have a different type of graph. Like in the next example, I'll show you bar graph. So there, this will become bar. Okay, so yeah, that's important to tell ggplot which graph do you want. And so you will require this kind of a graph when say you want to see the correlation between two variables. So here it's like wind versus temperature. So you can see as the wind increases, so as wind is becoming more and more, you can see the temperature decreases. And this is quite logical, right? I mean, if the wind is more, you'll feel more cold, and that means that the temperature is reducing, right? So yeah, so this is wind on the x-axis, temperature on the y-axis, and you can see that they are somewhat negatively correlated. Okay, so these scatter plots are actually used mostly for understanding correlation between two variables. Okay, so that was scatter plot. Now, if say you want to have a simple bar plot, also notice here in the scatter plot, you can have wind and temperature as numerical values. So these has to be numerical values. I mean, you will not actually plot male, female versus something else, right? So if you want a categorical data, you will actually need a bar plot. So how many males are there, how many females are there, and so on, right? So point for a point or a scatter plot, both of these variables should be numerical. They should not be categorical. It can be discrete, it can be continuous. That is okay. They should not be categorical. Okay. So yeah, so that was one thing. So that is why understanding data is important, because you need to know where which can be used. Okay, coming to simple bar plot. So let's say I just create a simple data frame where it just has one thing, the name. Okay, um, yeah, so here I'm just plotting this as a bar plot. So it says ggplot. I give the data frame, so that's data 0. Yeah, and then I say aesthetics x is equal to name, so that means this is what I want, and I just have one. only one variable, that is name. And then what I want to do is I want to count how many A's are there, how many B's are there, and how many E's are there. So A, B, E. And this says there are two A's, so there are two A's, one B, and two E's. Okay, remember, so over here, if you see, this is a categorical data. This is not a numerical data, right? A categorical data. So here you can have male, female, the different smoke, how many occasionally smoke, how many smoke. We can actually have that. So let's say that was the survey data set. Dollar smoke. Oops. So here I should have smoke. I guess the S is capital. Let me just check. Yeah, the S is capital. So you can also read the errors. So it says smoke not found. That means there's some spelling mistake because of which I'm getting this error. Yeah. So this is useful like this. So you can see there are these many heavy smokers. There are a lot of people in this survey who never smoke. So this is like kind of a healthy population probably, because there are a lot of people that don't smoke. There's some that occasionally smoke, some regularly, and there are some missing values as well. So NA means missing values. So that is also there. Okay. So yeah, so this is how you can actually use a bar plot with only one variable. So here you can see I've just defined one X. It is okay even if you don't write X. R will understand that that is the only one variable that is there with it. And then you can, and so this geom bar, you realize that it was point initially. So if you want a point graph, this will be point. If you want a bar graph, you have to write a bar. So this is geom means actually geometric transform. So yeah, so which geometric transform do you want? So I want a bar graph. Okay. And actually this counting is also actually a variable which is a default variable. R calls it statistical transform. So the statistical transform over here is count. So actually this is what is default. So you don't need to actually specify this, but if you want to do something else, then you'll have to specify. Okay, I'll come back to that. Okay, now let us say we want an x-axis and a y-axis. So there is name and there's some value. So say a dummy data frame where there is A, B, E, and then I have some values. So say these are number of students in a particular, I don't know, particular division across the year or something, I don't know. So this A has a value of 5, then there is one more A that is value of 10, there's B value 45, E 20, and E again 5. Okay, so now if you see, this data is different from this one, because here there are two things, name and value. So now you'll have to actually specify what you want. Okay, so say this is the same, so I put the data frame, that is data 1 over here. The aesthetics, say I want on the x-axis I want the name, on the y-axis I want the value, and then so actually you can see there are like two A's, one B, and two E. So if you don't specify anything over here, it actually does not know what to do, right? So if there is nothing, by default there is count, but then you cannot count two things. I mean, what to do? So R is actually very confused, and it gives an error. Okay, so you can specify this identity. So by identity, what happens is A, it has 5 and 10, both of these are added, and then you get A as 15 over here. And then there are two E's, so that E is over here, and those are also added, and then you get some 25 over here. So 20 plus 5, 25. and there is only one B, so that is 45 over here. So identity actually means sum in R. Just putting a comment so that you understand. So identity is equal to sum. I don't know why did they put this name, but yeah, they have identity. Okay, so here you sum all the values that are similar. Okay, then say you want to calculate the mean. Okay, so if you want to calculate the mean, what you do is you say statistical transform is equal to summary. If you remember the summarize function, the summary comes from that, and then you say function is equal to mean. So that will give you the mean. So a mean of 10 and 5. Yeah, mean of 10 and 5 is somewhere close to 7. So here you can see that. This is 45 because there is only one value, and then this is the mean of 20 and 5. 20 and 5. Okay, you can also change this. You can have say max over here. So that will give you the max value. So maximum 10 is maximum 45, maximum is 20. You can play with this. Okay, where is this useful? So maybe you remember the air quality data set. Now say you want to plot the mean temperature in the different months. So you can do that with ggplot. So this is the data set, air quality. Aesthetics, on the x-axis I want month, y-axis I want temperature, and then I want the bar graph, and then you can say summary function mean. So this will give you the mean temperature in every month. So this data has only months 5, 6, 7, 8, 9, and then the mean temperature in the fifth month was this much, about mm, greater than 60 but less than 70, I guess 76, 66, yeah, but then something like this. So this can give you a good visualization of your data set. You can also type say maximum, how much was the maximum temperature, so that is also that you can get over here. Okay, so this is how you can actually visualize your data using ggplot, very important function. And yeah, so this was just an introduction where I've shown you a bar graph and point graph. In the next video we'll explore further different plots. So that's all for this video. Thank you so much for watching. See you in the next video.